Okay, in today's lesson, we're going to be learning about writing a function. So we're kind of going to take a look at a couple of the things that we've been learning about so far in this unit. We first looked at patterns, and then we looked at relations and determined whether they were a function, and now we're going to actually write a function rule. So you have this note-taking handout in front of you, and so we'll just kind of go through it together. It says a function is a relationship that assigns exactly one output value for each input value. For each input, there is only one corresponding output. A function rule such as c is equal to p plus 0.06p is an equation that describes a functional relationship. So in example 1, suppose you're washing and drying clothes at a self-service laundry. The relationship between the number of loads input and the cost output is a function. Use the table to write the function rule. So when I look at these, I want to see how they're changing. So one way is looking at the number of loads. Each time it goes up by 1, right? So it's increasing by 1 or adding 1 in the domain. Okay, and then how is it changing down here? Well, it's adding actually 2.75. So you can, take a look at that and how we looked at the patterns, the geometric or the arithmetic patterns, and you can try to find a common difference or something like that here. And we see that we're adding the 2.75 each time that we move over. Okay, so it's kind of hard to write on this. So adding 2.75. So looking at this one right here, when x is equal to 1, it's kind of like the unit rate, right? If you recall, when we did our constant of proportionality, we always looked at the ratio of y to x. And so this input is x, the output is y. So we can see that we have $2.75 times the number of loads. So let n equal the number of loads, c is the total cost, and then we write c is equal to 2.75 n. So our function rule is right here. And you could try it out to make sure. 2 times 2.75, and you get 550. 3 times 2.75, and you get 825, and so on. So let's check this with a quick check. Let's write a function rule for the relationship between the number of hours, the input, and the number of miles, the output. So they're kind of telling you the x and the y. So if the hours are increasing by 1, and it looks like the total miles are increasing by 60, you have kind of a similar situation. So we have our right here with the x equal to 1 and the y equal to 60. Y is equal to 60x. So that kind of looks like that proportional relationship or that constant of proportionality like that. And we talked about writing those rules from tables. So this is very much like what we did before. Let's look at example 2. In this case, the relationship between the number of houses and the number of toothpicks is a function. Use the table to write the function rule. So we increase by 1, and we increase here by adding 5 each time. Okay. So then I would look and see if I could just take this, right, the x times 5, but I can't. If I take it times 5, my output is 6, so I'd have to add 1. So let me try this one. 2 times 5 is 10 plus 1, and then 3 times 5 is 15 plus 1 is the 16, and 4 times 5 is 20 plus 1. So my rule then becomes this. So they've identified the variables, let n be the number of houses, t be the total toothpicks, and translate it into a rule. And what we would have found in looking at our constant of proportionality, that it wasn't the same constant rate. We couldn't just multiply the x times some certain number and get the output. So we would have said that's not a proportional relationship. It is linear. It will be a straight line. It just will not go through the origin. So that's going to be how we relate that to what we've already learned. Okay, so with your quick check, let's give this one a try. So here's your input and output. It says, could a set of houses be built with exactly 12 toothpicks? How many toothpicks are needed to make 7 houses? Write a rule, and so forth. So I would almost skip ahead and do C to write the rule. To C. So writing a rule for the function, we would have this going up by 1. This is changing by a positive 3. Okay. But when I look at the first one, I'm not multiplying by 3. But if I multiply by 3, 1 times 3, and then the output is 5, so I could add 2. So let's try that with this one. 2 times 3, and then that would be 6, plus 2 would be 8. 3 times 3 plus 2. So my rule could be 3x plus 2. Okay. And the answer to could the set of houses be built with exactly 12 toothpicks? No. To make 7 houses, if we had the x equal to 7, right? The y, let's kind of extend this here. I'm trying to make a little dot, dot, dot to make up the difference there. So 7 times 3 is 21 plus 2, so we would have 23 toothpicks to answer those questions. Then if we turn the page, we'll get to the top there. And we did also talk about the dependent and independent variable when we were working with our constant of proportionality. We talked about that the dependent variable always depends on the value of the independent, and the dependent would be the output or the y value, and the independent variable might just be changing with time or something like that. It doesn't really depend on the other one, and so that'll help us determine in our functions and how to write the rule. So let's take a look at this a little bit better and get it in focus. So the table and graph model a function relating the storage capacity of a memory stick and its cost, identify the independent and dependent. So the cost is dependent because it depends on the storage capacity of the memory stick, and memory is independent. So let's try the quick check. The cooking time for an unstuffed turkey is about 20 minutes per pound. What are the independent quantity and the dependent quantity in this situation? So let's think about that. Independent equals the pounds, right? And dependent is the cooking time, because because it depends on how big the turkey is, right? Or it depends on, yeah. Depends on the size of the turkey. That's a lie. Yeah, okay, turkey. Let's try a few more exercises here. So let's get some practice. So relationships in the table below are functions. Write the function rule for each. So I like to look at this as, this is the x value, right? And it's going up by 1 every time. Okay, what's going on over here, right? We have plus 4, plus 4, plus 4. So the relationship between these two would be, let's see, 1 times 4 equals 4, 2 times 4 equals 8, 3 times 4 equals 12, and 4 times 4. So our rule would simply be 4x. It's a very proportional relationship. Okay, how about number of cans of frozen orange juice? Going up by 1. And how is it changing here? It looks like it's increasing by $1.25 each time. Okay, so 1 times $1.25 is $1.25. 2 times $1.25 is $2.50. 3 times $1.25. So our function rule could be y is equal to 1.25x. Okay. This is increasing by 1. This seems to be going up by about 25 each. All right, but 1 times 25 does not equal 65. And 2 times 25 is 50, and it looks like the difference there is 40, so I wonder if I take 25 plus 40, what would I get? And then take 3 times 25 plus 40, so let's try that. As a rule, 25x plus 40. And it works for all of them. Okay, these are going up by 1. Okay, and this looks like it's going up by 6 each time. So 1 times 6 is 6, and to get to 10 we have to add 4. So 2 times 6 is 12, and plus 4 is 16. And 3 times 6 is 18 plus 4. So we have the rule of 6x plus 4. So a lot of times you're just looking at the relationship between the x and the y. So which one of these are independent and which is dependent? Remember, the dependent variable depends on something else happening. So the cost of a long-distance telephone call increases with the number of minutes of the call. So in this case, the independent, I'm going to just use I here, is equal to the number of minutes, right? Because the dependent is the cost, and it depends on how long you talk. For the water pressure, it increases at 0.44 psi, that's pounds per square inch, with each increase in 1 foot in depth below sea level. So your independent happens to be your measurement of the feet below sea level, and then your dependent is the water pressure.